Hello and welcome to the Daily Space for today, June 1st, 2020. Um, Good morning and welcome again to Monday. I'm not going to lie, my teleprompter is nowhere to be found right now because it's just that kind of a Monday. This particular weekend was one that showed the greatest extremes in this experiment we call the United States of America. On one hand, we saw the tremendous return to space of NASA astronauts on board a rocket built here in the United States and launched from Florida. This was a mission that showed what our mixing pot of a nation is capable of when we allow our greatest minds to work to their greatest potential. At the same time, all across these United States, we've seen combinations of peaceful protests, police violence, and periodic riots. CosmoQuest has a policy against discussing politics, one I have to constantly repeat, even to myself. We are the place where we want you to feel safe, focusing on science while you escape from this world that we don't always wish we were on. We want you to be able to escape here into other worlds than this and to journey out into the stars. All are welcome here, and I want to read you part of a statement I wrote in 2016 during a previous period in this world where we saw refugees washing up dead on the shores of Mediterranean nations, and the first of many risings of Black Lives Matter as people tried to say, please don't throw our lives away. I want to read that statement now. This is a place, CosmoQuest, where people are accepted without regard to their color, culture, religion, or lack of religion, their education level, their wealth, or their caste. We do not care who you love, but only that you find love in this world. We believe that everyone can do great things, and we want you to be part of us doing great things. If you have the capacity to act, please help those who need it. If you need a safe place for your mind to find sanctuary in science, please come here and be welcome. This week is the American Astronomical Society meeting, which is like so many conferences being held in virtual spaces. This is going on simultaneous with the SpaceX meeting, going on simultaneous with all of these world events. We're going to follow true to our mission of bringing you science. And as we so often do, we will be providing simulcasts of press conferences from the AAS meeting, allowing you to see the latest in what is happening in science. We are also going to be working to bring you, as always, the daily space right here at our regular time and place. Our first story of the day doesn't actually come to us from the American Astronomical Society meeting, and that is not actually the correct slide that is currently up on the screen. Our first story comes out from last week. It came out while we were on hiatus, but we're still going to take it on because it came out with the title, "The Cow Mystery Strikes Back." And what may be the most confusing scientist quote I have ever seen. The quote is, "When I reduced the data, I thought I made a mistake. The koala resembled the cow, but the radio emission was as bright as a gamma ray burst." This quote came from Anna Ho, a graduate student at Caltech and lead author of one of the two papers related to this study. She was referring to supernova 2018 COW, which has an algorithmically determined name that just happens to spell out cow. That particular supernova became famous for being 10 to 100 times more luminous than a regular supernova. In a paper in Nature, two competing teams came together to describe the cow as either a newly formed black hole in the process of accreting matter or the frenetic rotation of a neutron star. One of the key features of that system was an unusual blue optical transit. The koala in the quote was a second object with the license plate designation ZTF18ABVKWLA. Those last four letters, KWLA, are what gave it the name the koala. This object wasn't called a supernova, but was instead referred to as a fast blue optical transit. Now a third object with no cute name has been found. It is CSS 161010. This object was discovered through its radio and X-ray emissions, and like the prior two events, has a fast blue optical light pattern. It was also observed to be ejecting material at a significant fraction of the speed of light. In astronomy, finding three things that act the same means you have found a pattern. And it's cause to declare the discovery of a new kind of object. This new kind of object is being called a fast blue optical transit, or F-bot. Yes, folks, an F-bot. And it is classified as objects that look like supernovae, but have bright blue transient optical components superimposed on the normal supernova components, and appear to also have fast ejected material if you're able to get in there and observe it fast enough with the right kind of instruments. This work was described in a pair of papers in the Astrophysical Journal Letters and in the Astrophysical Journal, with lead authors Diana Kopejans and Anna Ho. These papers describe the likely origins of this blue outburst as being the shock waves of a supernova hitting surrounding material. This paper was likely written without knowledge of the paper we talked about 2 weeks ago that described gamma ray bursts as being the result of binary systems. This paper reflects on the prominent model of gamma ray bursts as being single star explosions with powerful jets and without an understood origin for those jets. This model, with these new objects, advocates that F-bots are single object explosions with a surrounding disk of material that generates a disk and transient blue light. Now, I honestly wouldn't be surprised if we discovered that these F-bots are just gamma ray bursts seen at a different angle, or binary systems with a different secondary star than those discussed in the gamma ray burst explanation paper of a couple weeks ago that saw gamma ray bursts as being caused by massive carbon-oxygen burning stars that had a neutron star companion that stirred up its own jet when the carbon-oxygen star collapsed to form a additional neutron star. These are early days, and I kind of feel like we're at a point where everyone needs to take a breath and reconsider these ultraluminous objects and all these different models and come together to see what kinds of evolutionary and unified models are possible. This is a reflection on how science is changing so rapidly right now. For a couple of decades, folks have been saying we live in the golden age of astronomy. I think, as today's stories will make clear, we're ready to upgrade from golden age to maybe like platinum age of astronomy, as this discovery and so many others are made possible through a new era of astronomical instruments. For instance, the Espresso instrument, which is brand new and just starting to publish results. Well, this brand new spectrograph attached to the Very Large Telescope down in Chile has determined that the nearest star to Earth, Proxima Centauri, has, without a doubt, a Earth mass planet estimated to be 1.17 Earth masses, or maybe a little bit bigger. And this world is in that little red dwarf star's habitable zone. Now, this doesn't mean it's habitable. What it means is we have spectroscopic confirmation that our world is not alone, life confirmation not included. Proxima Proxima Centauri is very different from our sun. It, as I said, is an active red dwarf, something 80 to 100 times the mass of Jupiter. And this planet orbits the star every 11.2 days and is tidally locked to that star the same way the moon is tidally locked to Earth, always showing the same side of that world to its star. The system also appears to maybe even have a second planet that was determined by Espresso. And that second world may be 1/3 the mass of the Earth, making it the smallest object found via stellar velocity Doppler shifting. Now, once we have the tens of meter class telescopes that are in the process of being built, we'll be able to explore this world and see if it has an atmosphere, and it's going to be easier to imagine someday maybe even visiting this world, which is just 4.2 light years away with, well, our first attempts at interstellar travel. This work is published in Astronomy and Astrophysics and is led by A. Suarez Macasoreno. From advances on the ground with Espresso, we are also seeing advances from space. Observations from the Hayabusa 2 and the OSIRIS-REx mission have allowed us to see in unprecedented detail just what rubble pile asteroids look like when you get up close and personal. And this allows us to see exactly how tiny the rubble in these rubble pile asteroids actually is. These images are leading to improved computer models that can actually recreate these worlds, Ryugu and Bennu, that have been observed. And let us imagine, well, exactly how they might have formed. It truly is amazing to see just what can happen when minor planets undergo world-shattering events and gravity pulls the pieces back together. From the advances brought to us by Hayabusa 2 and OSIRIS-REx, we now look forward to advances being brought to us by the Parker Solar Probe. This cool under solar pressure mission is just completing a passage through Comet ATLAS's ion tail and is preparing for a June 6th passage through its dust tail. It was discovered recently that Parker's orbit is such that with minimal effort, it can do scientific observations as it goes through parts of Comet ATLAS's, well, tails. This is one of the first times, if not the very first time, that we've been able to repurpose a spacecraft to chase down a comet in real time while being able to continue on afterwards with its primary mission, which in this case is to observe the sun up close. We can't wait to bring you the results in the coming months from these currently underway observations. And finally, advances in computing are now allowing us to reimagine how the dinosaurs died. In a paper published in Science Advances with lead author D.A. King, researchers describe how the Chicxulub impactor dug not just down through the surface, but all the way down into the groundwater table, which is something we probably would have figured out if we thought it through before. But they're showing how steam would have massively erupted out through the crater rim, perhaps forming those cenotes that we see down on the Yucatan Peninsula. This would have meant that the dinosaurs died through a combination of, if they were too close, massive shock wave that sometimes accelerated them at escape velocities out through the atmosphere of the Earth, and otherwise just ruined their day. They would have died due to the steam being emanated through this event, and they would have ultimately died as our atmosphere was heated up by all the debris that was lifted up coming back down and shedding its kinetic energy as heat energy into our world's atmosphere. And this, of course, would have all been followed by a period of darkness as the dust continued to be in our atmosphere. It was a bad time to try and be alive, and a lot of things failed at the being alive part. Luckily, not everything failed, and we now exist for better or worse. And for better or worse. That's all the science I can fit into today's episode. Oh my goodness. Oh my goodness. So much science. But well, that's the end of the science for this episode. That isn't the end of the science for today. As I said, we are going to be bringing you American Astronomical Society press conferences as they happen. The next one is scheduled to go live at 3 p.m. Eastern, noon Pacific. That is 8 p.m. London time. And we will be here live, taking your questions, relaying them on as needed, answering as we can, and just keeping the science flowing while all the chaos goes on around us. We're your safe place. So come join in the science with us. And that's all I've got for now, but I will hang out and answer your questions for a few minutes. And as Keeper of Maps puts it, the science must flow. And here's an image I forgot to show you of the imagined terrestrial world at Proxima Centauri. So what have you got for questions? Well, you type them in. I'm going to remind you that, as always, my name stays Dr. Pamela Gay, and I wrote today's episode. We will sorry, let me start that sentence over. Today's episode was written by me, Dr. Pamela Gay, and will have its audio and video engineered by Ali Pelfrey and web content produced by Beth Johnson. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions and volunteer efforts of a myriad of individuals. Thank you, Arnstro, for the bits. I don't think I have a dog down here. I do not. Thank you for the bits, Arnstro. These are the things that keep us going. Thank you all for being here. That's an excellent statement, team. I'm just going to call you team. Drake's equations are the Mount Everest of all math. I wouldn't quite say they're the Mount Everest of all math. That may go to string theory, but they're definitely the pinnacle of how we look to understand the potential for life in our universe. So Veronica Kier asks, how far away is the world near Proxima Centauri? Oh, it's super close. I don't know how close is super close, but tenths of AU, I believe. Let's go through and see what other questions we may have. Arnster, you're not allowed to get sick. Oh, we have a title issue again. I am so sorry. We're just going to live with the title issue right now and fix it in post. Oh, that's on me. Okay, I'm not seeing earlier questions. Title was fixed. Oh, thank you. It goes around. So I caught how quickly it goes around Planetary Pan. What I didn't catch was its distance. So if there are no other questions, I'm actually supposed to be simultaneously in another telecon, but doing this was more important. So I'm skipping that telecon, but I'm going to work on pulling up that telecon's information while I, that's even smaller than I thought, Planetary Pan. Wow. 0.06 AU. That's tiny. That is very tiny. Very tiny. Thank you, Veronica Cure, for the sub to Serjanov. Thank you. Yes, Daily Spaces. It's not a random telecon. It's just a conflicting telecon. Yes, I will be streaming more AAS. I will be back at 3 p.m. Eastern, noon Pacific, 8 p.m. London, to bring you the next press conference from the American Astronomical Society. Thank you, Veronica Cure, for the gift sub. Thank you. I'm happy. We right now more than ever are watching our pennies and looking at our budgets for the very simple reason that I really want to be able to start providing benefits to our staff members. Right now, as it stands, all of us are getting our health benefits, either in the case of Annie, she's a vet, and the other three of us all have our health benefits through our spouses. And I really am not comfortable with the fact that the only reason we have health care is we're either married or a vet, and none of us have retirement accounts or anything like that through our employment. Now, because we're part-time employees, this isn't unexpected, but it is something that nonetheless, because we are all working 20 hours a week or more, it is something that we can provide if we can raise the funding. It is an additional, I believe it's 35% on top of everyone's salary. So for every dollar we pay someone, I need to come up with an additional 35 cents to go strictly towards benefits. It's not a huge change, but it's enough of a change that it's really hard. It's another 30% in donations we need to bring in every month. 35% in donations we need to bring in every month. So, yeah, these things really matter. Yeah. I don't think, I know I don't have dental care currently. Annie doesn't have vision. I can't speak about Beth or Allie, but these are things we want. Oh, Ironheart, you joined us just as we were getting ready to go off air. Anyways, thank you for your donations. They really matter a lot. This has been a product of the Planetary Science Institute. Now I will be back in just a couple of hours, but for now I'm going to run away to a telecon. And I'm going to tell you before I run away, try and have a good morning, evening, or let's go with safe. Everyone have a safe morning, evening, or afternoon, wherever in the world you may be. Wear a mask if you go out. Stay in if possible. And we're going to get through all of this together. And I will see you on the other side. Bye-bye, everyone.